Using the information on the left, we need to be able to find the value of x. Using the ruler postulate, we know that the distance between A and B is the absolute value of x2 minus x1. I'm going to use the value of B for x2 and the value of A for x1. We have absolute value of 16 minus a negative 20. Simplifying that, we have the absolute value of 16 plus 20, which is the absolute value of 36, or just 36. Now that does not give us the value of x yet. We know that the total value of 36 are the segments AM and MB put together. So we have AB equals 36. And then we can also say that AB equals AM plus MB. So AM plus MB also equals 36. Substituting in the value of AM is x squared minus 4x. X squared minus 4x plus the value of MB is 6x plus 1. Simplifying this, I can combine my like terms. I have x squared plus 2x, and I can bring over the 36 from the right-hand side by subtracting. I have x squared plus 2x minus 35. And now this brings us into a quadratic, and we have several ways to solve quadratics. I think the easiest way to solve this x value is to go ahead and factor. I'm going to look at this. I need two numbers that multiply to negative 35, but when they add, they give us 2. So I need two numbers that multiply to negative 35. If I use a 7 and a 5, and then 35 is negative, so I know that they're going to be opposite signs. The greater number is 7, so the greater number is going to keep the sign of the 2. So I'm going to have positive 7 and negative 5. So when I factor this, I'm going to have x plus 7, x minus 5. If I check my work again, I have my x squared. I have 7x minus 5x gives me 2x, and 7 times negative 5 is 35, so we are good. Now remember, these are factors if we're going to get the value of the x. We could simplify this and say x plus 7 equals 0, or x equals negative 7, and then x minus 5 equals 0, or x equals 5. And if we substitute these values in, let's say our negative 7 right here, let's say we're going to take the 6x plus 1, 6x plus 1. Let's say we put in that value of negative 7, 6 times negative 7 plus 1. That's going to be a negative number, so we are not going to use negative 7. It only makes sense in this case to have a positive number for a measurement, a distance. So we are going to use x equals 5. So we have find the value of x equals 5. For section B, find AM. AM is x squared minus 4x. We are going to write down x squared minus 4x equals segment AM. We're going to substitute in the value for that x. So we have 5 squared minus 4 times 5, which is 25 minus 20. We have a length of 5 for AM. Going on to segment MB. MB is 6x plus 1. MB equals 6x plus 1. And again, substituting in 5 for x, we have 6 times 5 plus 1, which equals 30 plus 1, or 31. I'm going to write up here, we have 31 for MB and 5 for AM. Now find the total distance of AB. Now what we could do, we could come back over here on the right-hand side. Right here and at 36, and we could say that it's 36, or we could also take measurement of AM and add it to MB in the smaller values, AM plus MB, and AM equals 5, MB equals 31, so our total is 36, and it does match what we had up here. Okay, very last thing, what is the coordinate of M? In order to find the coordinate M, we need to know the measurement of the line segment AM and add that to our starting point of 20. So we have A is negative 20, and we are going to use move over. AM is 5 segments to the right. We are going to move 5 segments to the right, which is adding to the right-hand side. So our coordinate of M is negative 15.